Okay, I'm sorry. I'm ready now. Sorry about that. Okay, we're going to use identities today. Wheat and coal.
Alright, we're on a different page.
We're going to use identities to solve trig equations. Yesterday all we did was factor. We didn't really use our identities. But today we're going to have to use them. Okay, and we're going to find all the x that satisfy the given equations for 0 is between, or x is between 0 and 2 pi. So, first thing though, you can always set it equal to what?
0. 100.
Okay, so we're about right here. How do we set that equal to 0?
Subtract 3 cosines x plus 3 minus 2 sines squared x.
You want to subtract this one?
Yeah.
Okay. So 3 cosine x
3.
plus 3 minus 2 sine squared x equals 0.
Rearrange it.
Yeah, can we?
Well, it's sine and cosine, so you can't really
factor that, can we? Because we got sine and cosine. So what about, what's the identity for sine squared x?
Sine 2a.
1 minus cosine.
Yeah.
1 minus cosine squared x. Remember, cosine squared x plus sine squared x equals 1. Remember that one? Okay, that's the one we're using. So sine squared x would equal 1 minus cosine squared x. So we're going to replace that. We'll do 3 cosine x plus 3 minus 2 parentheses.
1 minus cosine squared x.
Yeah, so now we're just going to put sine. 1 minus cosine squared x.
Equals 0.
Now everything's in cosine. Let's get it all simplified as much as we can.
Distribute that 2 out.
Okay. So we have 3 cosine x plus 3, what?
Minus 2.
Plus 2 cosine squared x.
Okay. Okay, and then we can combine the 3 and the negative 2, right? What would that be? 1. And then let's put it in an order where we can factor it. What would be
2
first?
cosine squared x.
Yeah, put your squared part first.
3 cosine x.
And then your 3 cosine x, and then plus 1, right?
Do 2 cosine.
Okay, is everybody okay up to this point, though?
Yes.
All right. Now we can factor this into 2 parentheses, just like we did yesterday.
Cosine, or 2 cosine.
And
2
cosine
cosine
x.
and cosine plus 1 plus 1.
Okay, to get 1, we'd have to do 1 times 1 or negative 1 times negative 1. But since this is a positive 3, we'll do plus and see if this works. So we get 1 cosine x plus 2 cosine x. Is that 3 cosine x? Yes. Okay. So what do we do after that?
Somebody said 0 equals 0.
So 2 cosine x plus 1 equals 0, and cosine x plus 1 equals 0.
Cosine x equals negative 1. Cosine x equals negative 1.
Okay, and then we'll divide by 2.
Negative 1/2.
Cosine x equals
Negative 1/2.
negative 1/2. And this one, cosine x equals?
Negative 1.
Okay, and I'm running out of room. Okay, when is cosine, they're both negative. When is cosine negative?
And the second and third.
Yes, right here, I did that wrong. It's positive here. This is all students take classes. So cosine's positive in 1 and 4, negative in 2 and 3.
Yeah. And the 1/2 of
Cosine of
x of
1/2.
1/2 is 60 degrees.
60 degrees.
So we get 120
Okay.
and or
what would that be?
2
Pi over
3.
something over 3,
2 pi
right?
over 3.
2 pi over 3 and
4 pi over 3.
that would be 4 pi over 3. Okay, so we have x equals 2 pi over 3 and 4 pi over 3. And then when is cosine of x negative 1?
Left.
Yes, right here.
So could you do
That's all of those.
2 pi over 3?
Oh.
Or how could you show like in between them, like, cause it's in between 2 pi over 3 and 4 pi over 3.
No, it's not in between. I mean,
Isn't it?
no, it's just these answers.
Okay.
Okay. And you could put them in a different order, but it's still the same thing. Okay, we only have these 3 to do, so it's not too much. Only thing different from yesterday was replacing that sine squared x with 1 minus cosine squared x. It's really the only difference. Okay, how about this one?
Subtract cotangent, or subtract
I'm gonna subtract the one on the right, okay? Guys, I'm gonna have to separate you two over here.
No. He threw my plate in the floor.
Okay, the problem is though, I've got cotangent and I've got cosine. Can I do something about that?
Change cotangent to 1 over sine, or tangent.
Yeah, whoa. We just got trippy on
Cosine over sine.
How about cosine over sine? I like that.
Yeah.
Okay. That way, at least I have a cosine in there.
My love.
That's
Except
okay.
1 over cosine.
Actually, we probably shouldn't have set it equal to 0 first.
It's okay, we can do it.
Yeah, but it's gonna be harder.
We've got this.
Let's go back.
It's okay. Multiply. How are we gonna get rid of that sine x? In the bottom?
1 minus
Multiply by-
cosine x. Oh wait, you can't do that.
Put a 1
It's not
over
squared.
square root of 2 cosine x and put that over 1.
How about if we multiply everything by sine x?
Okay.
Whoa.
So it'd be
Whoa.
so it'd be cosine x minus square root of 2 cosine x sine x equals 0.
The
You're right.
And then it would be,
Why is this? Everybody understand where we got this from?
No.
Look at here. How did we get cosine
Oh,
x
you
from?
cancel those bad boys.
Yeah.
And it's just cosine. Gotcha.
Now it's okay to cancel if you add this in. Okay, that's okay then. And we wouldn't have had to cancel if we hadn't set it equal to 0 first. Okay, are we all right now?
Yeah.
Now, understand where it all came from? Okay. So now we can factor out a what?
Cosine.
Cosine. And so what do we get inside the parentheses?
1.
1
Minus
minus square root of 2 sine x
Equals
equals 0.
0.
Then
Then what do you get from?
Cosine equal to 0 and 1 minus sine. Or 2 sine.
Right, we're going to set each one of these equal to 0. So cosine x equals 0, and 1 minus the square root of 2 sine x equals 0. Okay, let's solve this sine one over here.
So
Plus 1.
minus
Actually, you have to
Add
minus
square
1.
root of 2 sine
Don't
x.
you have to minus 1? No, you
No.
can't add
Or you
that.
can-
It's multiplied to that.
you can
You
add
just
the
add
whole
the entire
Get
thing.
the plus
yeah, you
1.
can add the whole thing so make it positive.
Wait,
You can add the square root of 2 sine x.
okay, wait. Let's just get sine x by itself.
Yeah,
Okay.
but that's what we're doing.
So let's
we're just
subtract
trying to
1.
keep it all positive.
It's all right. Let's subtract 1. You were putting sine x on the other side?
Yeah, that way
Okay.
it'd be positive.
I got you.
And we can square root.
It doesn't really matter. It's just negatives. Y'all can handle it.
And then
Okay, subtracted 1 from both sides, then divided by the negative square root of 2. So you get a positive,
Square root of 2.
right, because we got to change it to square root of 2 times the square root of 2, right?
it's going to be square root of 2 over 2.
And sine is x is at 45. right?
Does everybody understand that we got square root of 2 over 2 here?
Yes.
Okay, good. All right, so when is sine positive?
Pi over 4 and 3 pi over
1 and 2?
Yeah.
All students take classes.
Power of 2.
Square root of 2 over 2 is a 45, isn't it?
4.
So you're right.
Pi over
Pi over
4.
4, and this one would
3
be
pi.
3
3
pi.
pi over 4.
And then pi
And
over 2.
cosine equals 0 is power 2.
There's 2 of them,
That's
aren't
what
there?
Power 2
Yeah.
and
3 pi.
3 power 2.
3 pi.
Like that?
Yes, ma'am.
Okay, that's when cosine is 0. All right, now look back up at the original problem. We've got a cotangent.
Hmm.
But tell me, what is cotangent equal to?
Sine over cosine.
Mm-mm.
Cosine.
Cosine over sine, and so we're okay because well, not necessarily.
Yeah, sine and a cosine.
Yeah, sine and a cosine is fine. If I plug in, let's say, pi over 2, I can do the cosine of pi over 2. Well, what's the sine of pi over 2?
1.
Yeah, and we're okay, aren't we?
Yeah.
And if I plug in 3 pi over 2, the sine of
works.
3 pi over 2 is
1.
negative 1, and that's okay. You can have a negative 1 on the bottom. You just can't have a 0 on the bottom, right?
C.
Okay? That's when you have to be careful, is if you get a 0 on the bottom somewhere. Okay? And you only have to worry about the quadrantals. We don't have to worry about these at all. Just the quadrantals. You got to check and make sure they're okay when you plug it back in. The reason I didn't check this quadrantal, the pi, is because I didn't have anything in the denominator.
You didn't have any cosines or cosecants or secants.
Or any, yeah, cotangents,
Yeah.
cosecants, or secants. Right. Okay?
So everything will work out.
Right. So all of these are the answer. X equals,
Pi over 2, 3 pi over 2, pi over 4, and 3 pi over 4.
mm-hmm. Okay, the next one, a little harder.
Can't cosine equal tangent over sine?
Yeah, but then you have a tangent. That doesn't really help you.
You can cancel the signs, kind of. Because you could put sine over 1.
Then you'd still have sine and you'd
That's
still
a
have
bunch of
tangent.
work.
That's the problem with that.
Mm.
Good try though. What
Both
else? Any other
equals
ideas?
0.
Huh?
Both equals 0.
You
They're
can't.
married.
Yeah, they're married.
Stupid marriages.
Can you factor out a negative?
Well, but how would that help you?
Could you have
Negative sine plus cosine is what you have. Right?
Well, can you just
See,
well,
well,
then you
maybe
can set 1 equal to 0, which
How many numbers should be?
is what
Right.
we had them then.
Right.
Yeah.
Oh, I see what you were saying. You were trying to get it, be able to set them equal to 0. Okay, this is what we're gonna do.
Uh-oh.
Why am I doing this?
Good question.
What happens here?
That becomes 1
Okay,
minus
Minus
cotangent equals 0.
and now I just have one kind of
Cosecant.
function. I don't have a sine and a cosine. I don't have a tangent and a sine or anything. I just have one cotangent. That's it.
You blew my mind a little bit, but I understand it.
Huh?
You just
Okay.
blew my mind a little bit, but I understand
Okay, now the what else could I have done?
Cosine.
Cosine, exactly. Then you would get tangent minus 1 equals 0.
Divide everything by 0.
Okay. So really, tangent might have been a little easier, but now we have cotangent x equals negative 1, so cotangent x equals
1.
what?
1.
1. Good. So we got to figure out when cotangent x equals 1.
Oh, that's 45 degrees.
Okay, what is cotangent equal to? 1 over tangent. So 1 over tangent x equals 1, and then we can flip it. So tangent x equals, when you flip 1, what do you get?
1.
Not tax. Tangent.
I wish my tax was only 1.
Yeah, there we go. So when is tangent positive?
First and third.
Okay, right here.
45 degrees, so it'd be 45 and
215.
25.
225.
So it's going to be pi over 4 and pi over 4.
Yes. That's right. Questions?
Do we have to check those?
Good question.
No.
No, it's the original equation. No.
Okay. So pretty much just like you said. no,
And these are
all
45
quadrants.
degree angles, and the sine of 45 is fine, and the cosine of 45 is fine.
Quadrantals.
Just, yeah, right, just quadrantals are the only ones you have to check, and it's just if something's in the denominator.
Oh, I get it. Because sine x and cosine x are only the same
When, yeah,
and when they're both positive and when they're both negative.
Exactly.
Shortest page of notes
And-
we've ever had.
They're the exact same at 45 degrees because they're both square
Square
root
root
2
2
over
over
2.
2.
And one day when we had Friday, Friday, we didn't have any notes.
because sine of
So
45 would
it'd
be,
be like saying square root of 2 over 2
2
minus
minus-
square root of 2 over 2
Off
or
the
square root
negative.
square root of 2.
Negative.
We had no notes.
You got it, very
Or
good,
even
very good.
Oh my gosh, guys, okay.
Okay, if you haven't finished 5-1, do that first. And then you can work on
Fair enough.
5-2, let's do
Have to, let's do.
the
Odds,
Odds.
except for 1, 3, and 7.
We're gonna do the odds. Now, actually, let me see.
What, 5?
We're gonna do 1 through, let's do 1 through 8. Because we have tomorrow too.
1 through
Odds.
8.